Section 300.18 of the National Electrical Code addresses the minimum bending radius for cables operating at less than 600 volts. This section mandates that the bending radius must be at least 8 times the overall diameter of the cable. This requirement is applicable to a wide range of cable types commonly used in residential, commercial, and industrial electrical installations. These cable types include, but are not limited to, non-metallic sheath cable, often referred to as NM cable, underground feeder and branch circuit cable, known as UF cable, and metal-clad cable, or MC cable. The purpose of specifying a minimum bending radius is to prevent damage to the cable's insulation and conductors during installation. Exceeding the minimum bending radius can cause the cable to develop internal stresses, which may lead to cracking or weakening of the insulation. This, in turn, can create electrical hazards such as short circuits, ground faults, and ultimately, electrical fires. In addition to the safety implications, exceeding the minimum bending radius can also negatively impact the long-term reliability of the electrical system. Damaged insulation is more susceptible to moisture ingress, chemical attack, and physical abrasion, all of which can contribute to premature cable failure. Furthermore, sharp bends in the cable can increase the impedance of the circuit, leading to voltage drops and reduced efficiency. The requirement for a minimum bending radius is not arbitrary. It is based on extensive research and testing to determine the optimal balance between cable flexibility and structural integrity. Cable manufacturers specify the minimum bending radius for their products based on factors such as the cable's construction, the type of insulation used, and the operating voltage. The National Electrical Code incorporates these recommendations to ensure that electrical installations are safe and reliable. It is important to note that the minimum bending radius specified in Section 300.18 is a minimum requirement. In some cases, it may be necessary to exceed this requirement to accommodate the specific characteristics of the cable or the installation environment. For example, if the cable is being installed in a cold environment, it may be more brittle and therefore require a larger bending radius. Similarly, if the cable is being installed in a confined space, it may be necessary to use a larger bending radius to avoid damaging the cable. It is also important to consider the type of cable being used when determining the minimum bending radius. Some cables are more flexible than others and can be bent to a tighter radius without damage. For example, flexible metal conduit, or FMC, can typically be bent to a tighter radius than rigid metal conduit, or RMC. The National Electrical Code provides specific guidelines for the bending radii of different types of conduit. In addition to the minimum bending radius requirements, the National Electrical Code also specifies requirements for the support and securement of cables. Cables must be supported at regular intervals to prevent them from sagging or becoming damaged. The supports must be designed to withstand the weight of the cable and any additional loads that may be imposed on it. Cables must also be secured to prevent them from being pulled or displaced. The securement methods must be appropriate for the type of cable and the installation environment. The combination of minimum bending radius requirements, support requirements, and securement requirements ensures that electrical cables are installed in a safe and reliable manner. These requirements are essential for protecting people and property from electrical hazards. When installing electrical cables, it is important to consult the National Electrical Code and the cable manufacturer's specifications to determine the appropriate bending radius, support requirements, and securement requirements. Failure to comply with these requirements can result in electrical hazards and premature cable failure. It is also important to use proper tools and techniques when installing electrical cables. Avoid using excessive force when bending cables, and be careful not to damage the insulation. If you are not familiar with electrical installation practices, it is best to hire a qualified electrician to perform the work. Firstly, the general requirement for cables less than 600 volts, as stated, is 8 times the overall diameter of the cable. Secondly, this applies to NM, UF, and MC cables, which are common in residential and commercial wiring. Thirdly, exceeding the minimum bending radius can damage the cable's insulation and conductors, leading to potential hazards. Fourthly, always consult the NEC and cable manufacturer's specifications for proper installation guidelines. Fifthly, ensure proper support and securement of cables to prevent sagging and damage. Sixthly, use appropriate tools and techniques to avoid damaging the cable during installation. Seventhly, if unsure, hire a qualified electrician to perform the work safely and correctly. Eighthly, remember that proper bending radius is crucial for long-term reliability and safety of the electrical system. Ninthly, consider environmental factors such as temperature and space constraints when determining the bending radius. Tenthly, flexible cables like FMC may have different bending radius requirements compared to rigid conduits like RMC. Understanding and adhering to these guidelines is essential for ensuring a safe and compliant electrical installation.